Bhargav, you can start from the.
Good morning, everyone. It's my pleasure addressing you all through this online FDP program. Now let us all rise for the prayer song.
वन्दे मातरम् सुजला सुफला मलयज शीतला सस्य श्यामला मातरम् वन्दे मातरम् शुभ्रज्योत्स्ना पुलकितयामिनी पुल्लकुसुमित द्रुमदल शोभिनी सुहासिनी सुमधुर भाषिणी सुखदां वरदां मातरम् वन्दे मातरम् वन्दे मातरम्
About our institution, IIIT, Indian Institute of Information Technology, Tiruchirappalli, known as IIIT, established in the year 2013-14 as an institute of national importance under public-private partnership model by Ministry of Human Resource Development. IIIT is an academic and research institute funded by Government of India, Government of Tamil Nadu, and industry partners. The main objective of IIIT is to achieve world-class excellence in information and communication technology. Coming about this FTP program, Department of CSE and ECE organizes the faculty development program on the thrust area data sciences approved by AICT Training and Learning Academy ATAL. The coordinators of this workshop are Dr. R. Dhanalakshmi, Associate Professor, Department of CSE, and Dr. G. Sitaraman, Associate Professor, Department of ECE. The primary objective of this online faculty development program is to understand the insights of data sciences. This FDP covers the following topics: Introduction to data science, probability and statistics for data science, ecosystem tools for big data, introduction to Python programming, research challenges and opportunities in data sciences, AI overview, supervised learning and unsupervised learning, predictive analytics, reinforcement learning, dimensionality reduction for data sciences and analysis, industrial analytics and AI suites enabled by cognitive data lake and data models, recommender systems, and finally, high performance computing and big data. May I now request Professor N.V.S.N. Sharma, Director, IIIT Tiruchirappalli, to deliver the inaugural address. Please, sir.
Good morning, everybody. My dear coordinators and participants and other dignitaries. It gives me immense pleasure in welcoming you and inaugurating the 5-day online faculty development program funded by ATAL in the presence of academicians, participants, research scholars of various institutions, organizers, and others. I'm really proud to say that the AICT Training and Learning Academy, under the aegis of AICTE, is organizing the faculty development program for upgrading knowledge of faculty members throughout India. AICTE has taken a noble initiative of bridging the gap by training faculty members, which in turn will guide students in new emerging areas. ATAL Academy initiative envisions empowering faculty to achieve goals of higher education, such as access, equity, and quality. IIIT Tiruchirappalli takes pride in organizing the ATAL program on the sophisticated technology such as data science to enrich and train faculty members and research scholars. Data science, an interdisciplinary field, deals with processes and systems that are used to extract knowledge of or insights from the large amounts of data. Data science is a continuation of data analysis fields like data mining, statistics, predictive analysis. Data science uses a lot of theories and techniques that are part of other fields like information science, mathematics, statistics, chemometrics, and computer science. Some of the methods used in data science include probability models, machine learning, signal processing, data mining, statistical learning, database, data engineering, visualization, pattern recognition, and learning, uncertainty modeling, computer programming, and others. With the advancements of so much of data, many aspects of data science are gaining immense importance, especially big data. In addition, machine learning has enhanced the growth and importance of data science in the last few years. Data has real value, and every information extracted from it can make or break businesses. Analytics is the intersection of business and data science, offering new opportunities for a competitive advantage. It unlocks the predictive potential of data analysis to improve financial performance, strategic management, and operational efficiency. Data analytics can lead to valuable insights that can determine leads to increased sales, fraud detection, pattern recognition, and risk prediction in various domains. As part of this initiative, a faculty development program is conducted to focus on the fundamentals of data science with hands-on sessions using Python language. Therefore, the program is indeed an opportunity for the participants to understand and experiment with a spirit to become designers of tomorrow. I believe that the next 5 days will be a great learning experience for every one of you. Thank you.
We thank you for your support and encouragement, sir. The inaugural session is completed now. Let us begin the technical session. We have 3 sessions today. Let me introduce the speaker for session 1 now. Session 1 will be handled by Dr. C. Valliammai, currently working as Associate Professor in the Department of Computer Technology, Madras Institute of Technology Campus, Anna University, Chennai. Dr. C. Valliammai received her PhD in ICE in the year 2011. Professor is an expertise in the areas of grid computing, cloud computing, databases, big data analytics, and so on. She has over 20 years of teaching experience. As a faculty guide and as an investigator, received research grants of nearly 475 lakhs from Anna University, CTDT Anna University, DIT, UGC, etc., and executed various research projects. Dr. C. Valliammai has guided 5 research scholars, and currently 3 scholars are doing research under her guidance. Dr. C. Valliammai received Best Teacher Award from VIT in the year 1998. Also received Best Paper Award from IEEE Conference for 3 consecutive years, 2013, 14, and 15 respectively. Professor has guided 39 undergraduate and 19 postgraduate projects. To her research credit, she has published 24 papers in international journals, 29 papers in international conferences, 2 papers in national journals, and 2 papers in national conferences. Also, 19 book chapters she has published. Furthermore, Dr. C. Valliammai has organized nearly 15 technical programs like conferences, faculty development programs, and workshops. Today, we have such an eminent personality for handling the topic Introduction to Data Sciences. Now, I request Madam to start the session. Please, Madam.
Thank you, sir. Can I share my slide?
Yes, ma'am, you can start. You can share your screen.
but it's not allowing me to share. Dhanlakshmi ma'am?
Yes, we are checking. 1 minute.
Yeah.
Ma'am, you can share the screen, ma'am.
Now you can try, ma'am.
It's activated. Yes, ma'am. Yeah.
Valli ma'am, you can present your screen now.
Yes, ma'am. Yes, ma'am. So able to view my screen, ma'am?
Yeah, it is visible. You can go to full screen mode.
Yeah. So you want me to switch on the video, ma'am?
Yeah, you can switch off the video.
Okay, fine, ma'am. I can switch off the video
No,
now?
we are not able to see your screen.
Yeah, I can switch off the video now?
Yeah, yes, you can switch off.
Okay. Now able to view the screen, ma'am?
Yes, fine. You can start now.
Yes, ma'am. It's my great pleasure to deliver the lecture in ATAL FDP, it's in data science. Thank you, Dhanlakshmi ma'am, for providing a great opportunity. Very good morning to all the participants. I hope the participants will get a very good exposure in data science, who are doing research or who are going to start their research. Okay, the people will be getting benefited through this FDP. And my name is Valliammai. C. Valliammai, working as Associate Professor, Department of Computer Technology, MIT Campus, Anna University, Chennai. So my email ID given. If there is any queries, you can mail through this mail ID. So the outline of this presentation: first, why data science, and what is data science? What is big data and its challenges? And how the data sciences differ from databases versus data science, big data versus data science, business intelligence versus data science, machine learning versus data science, and the life cycle of data science and the applications of data science. Okay, this session is purely with the introduction part. Why data science? Okay, so it provides what new, exciting, effective applications of data analytics you can develop. So, for example, Google Flu Trends. So actually, this project was launched 2008 by Google to help to predict the outbreaks of flu. Actually, the Google Flu Trends predictions were 97% accurate comparing with the CDC data, that's a Center for Disease Control data. Okay. Actually, the prediction model is built on various data sources, types, and analysis. So what we can do, we can combine social data also, okay? But now the project is not active. But the predictions were 97% accurate. Okay, so combining social media data, example Twitter and CDC data, and structural models that infer the spatial and temporal spreading of disease. Okay, it can be done. So that's what is scope for the future. Okay, the next example too, that's a team of MIT. Okay, developed a machine learning model that leverages coronavirus data. They have used a neural network to determine the effectiveness of quarantine measures, okay, and how predict the spread of COVID-19 virus. So they have trained a neural network model with number of infected individuals who are all under quarantine, and using the quarantine, by quarantine, how we can avoid spreading. Okay, this was no longer spreading infection to others. Okay, that study was done by the team. So actually, we used by the quarantine, actually the COVID-19, okay, the spread was reduced. Okay. And in India also, the researchers at the IIT, okay, Delhi, they have developed web-based dashboard predicting the spread of COVID-19. It's actually mobile-friendly dashboard. Its name is Prakriti, Prediction and Assessment of Corona Infections and Transmissions in India. It provides detailed state-wise and district-wise predictions of COVID-19 cases in India for a week, 3-week period. Okay, so and which is updated on now it is weekly basis. So it's very helpful to the government. Okay, it's got to predict how they can prevent the spreading, and it's very useful for healthcare organizations as well as local and the central authorities to efficiently plan for future scenarios and how they can avoid spreading, how the resource can be allocated. The next example, please. AI predicts. Okay, there's it's a very recent one. There's AI predicts the winner of U.S. presidential election from tweets. The Democratic candidate, okay, this is Joe Biden, was a winner. Okay, so here, according to the news, this Dr. Herman makes. Okay, the statistical side. Okay, statistical person, City University of New York. He developed the model based on AI and data science. He has taken data from social media platforms. That's why he has taken tweets, Twitter data set, and he predicted the winner of this year's election. It exactly matches the actual result. So media is a combined the technology of big data along with AI to understand the opinions on Twitter. Okay, he combined the media informations and AI to understand the opinions on Twitter. Okay, he has collected the 1 million tweets from tweets, and he has developed the AI model, and he predicted the winner of US election. This is Joe Biden. Okay, that's a great great advantage, and it provides. And what is data science next? Next is what is data science? Here, data science is combines the machine learning, traditional approach, the statistical packages, and data. Okay, this is for data engineer. So first of all, we should be aware of substantive expertise. That is a domain knowledge. So domain knowledge, that is a practical knowledge used in data about. What is data about? For what data we are using. Okay, that's data knowledge should be there to the data scientist. So here, substantive expertise is much needed. So for example, you take the marketing, so you have to understand the customers and you have to define the metrics for that and translate for non-technical audience. And how can we understand the customers? We have to ask questions and make it actionable. Okay, this was substantive expertise, very important with respect to marketing. Okay, if you go with the medical field, so for example, DNA testing means a person involved in the research, he or she should be aware of the DNA, okay, the structures, everything. So next is traditional research. The statistical packages are used here, advanced math package, experimental design, model fitting. Okay, statistical packages are used. And machine learning, when it comes to the machine learning part, machine learning is here used for predictive analysis. Okay, here they have we can use the many scripting languages, and we can go with the hacking and coding parts, constraints. Okay, whatever we are doing is whatever model we are developing, so the constraints. Okay, it's very important. It's a privacy and legal because we have to get the right data. For example, suppose we are taking healthcare information. Okay, this was the healthcare predictive analysis. Sensitive information we are going to use. Okay, there we have to maintain the privacy. We have to maintain the legals. issues. Okay, then the data preparation is very important, and how we are going to govern the data governance, and how we are going to extract the data from the large volume of data. That is much more important. Okay, this is what the data science combines the concepts of machine learning, traditional research, it's a statistical information, statistical modeling, and data engineer point. Okay, this is for the data. So again, it's continued. That's data science, a blend of various tools, algorithms, and machine learning principles with the goal to discover hidden patterns from the raw data. So here the answer lies between the explaining and difference between explaining and predicting. So we can see here the analyst. Okay, the analyst will be very good in business administration and will be very good in explore data analysis. Okay, here the data scientist. Okay, should be very able to make the data product engineering. Actually, here we have to make the data to data product. That's the main motivation of data science. Okay, what data is available, that we have to make it as your data product. Okay, so data product engineering is a very important role of the data scientist, and you should be able to use the machine learning models and advancing algorithms. Okay, this for predictive analysis. And exploratory data analysis is also the major part of data scientist part. So here the data science is lies between explaining. Okay. And again, it's continued. The data science is a science which uses computer. The audience. Data science is a science which uses computer science, statistics, and machine learning, visualization. If you want to visualize your data in a readable form and for the visual form, and human-computer interactions to collect as well as collect the data, and clean the data for pre-processing and integrate. Okay, suppose you are more than one data source.
Hello, ma'am, 1 minute. See, all the participants are kindly requested to mute video and audio. Madhivanan sir. Hello, Madhivanan sir. இந்த மதிவானன் ஒரு
So here we are going to collect the data and clean the data. It's a pre-processing, and we have to integrate. So integration here is more than one data source. We are going to collect the data. So then we have to analyze and visualize the data and interact with the data to create data products. So when you take the computer science fields here, it's mainly using pattern recognition, visualization, and we have to use data warehousing, high performance computing, and database and BI. All these concepts are comes under this word. It's also with the data science. And mathematics part, we are going to use the statistical modeling. That's what the mathematical modeling, and the statistical and the stochastic modeling, and probability is used. Fine. The statistical model is actually the mathematical model which embodies a set of statistical assumptions concerning with respect to the sampling. Okay, that's for generation of sample data. Okay, so it represents actually how data generating process. So very helpful in analytics. And where does data come from? Lots of data is being collected and warehoused. Okay, earlier we have used centralized database, then it's a distributed database, then it is parallel database, then we came across the cloud. Okay, distributed systems, then next with the cloud, and now we are working with big data. Okay, this is with respect to that, the other things, the data warehousing, data mart. Okay, we are working that. So here the scientific experiments again generates large volume of data. IoT devices emits large volume of data, and Web data is also what large volume of data, e-commerce data, financial transactions, bank and credit transactions, online trading and purchasing, and social networks. Obviously, social networks and many more. Okay, so lots of data being generated through these points. Okay, this is what they're using with respect to IoT, financial transactions, customer feedbacks, and web data. So using social network, from social network, online trading and purchasing, lots of data is being collected and warehoused. Okay, that's why it's called, it's a big data. Earlier databases, you can able to do the processing. Okay, it's a processing will be storing and accessing, analyzing. Okay, there's in traditional databases. Okay, it will not support the big data. Big data are sets large, so complex. Okay, so the traditional methods of storing, accessing, analyzing the data, okay, will not, what's too expensive. Okay, so we have to, what we are going to do is the potential value hidden in the data we have to identify. So the big data technologies and approaches are used to drive value out of data-rich environments in ways that traditional analytical tools and methods cannot help that. Traditional analytics tools are available. That's what data mining tools are available and data warehousing tools are available. Okay, that will not helpful to extract the data and do the analytics in on big data. So because the big data is the high volume, high velocity, high variety of information. High volume means volume of data, scale. Okay, scaled data. Okay, the velocity, the speed. Okay, the speed of data generated is we cannot say how much speed. It's the speed of data. The variety. Okay, the different formats. Okay, the different formats of data we are going to use, such as structured, unstructured, semi-structured data, and video, audios, all type of data is going to support. So the big data is high volume, high velocity, high variety information, assess that demand cost-effective, innovative forms of information processing that enable enhanced insight, decision making, and process automation. This is a definition with Gartner. He only coined the three V's. Three V's, that's a volume, velocity, and variety. So we, as of we know that the big data is what the voluminous of data is much complex. Okay, that's what earlier we started working with kilobytes, megabytes, and gigabytes, terabyte. Now it's a petabytes, then exabyte, then zettabytes and yottabytes. Okay, now we are crossing yottabytes of data. Okay, so the data velocity also increases, the speed at the data is generated. Okay, that is all. So earlier it's a batch processing. The next periodically we'll be getting data. The next we are real time. Okay, real time streaming data. Okay, then if it is the batch processing, we can make use of the tables enough. If we go with the periodic data, we are making use of databases are used. Okay, the Oracle, Sybase, DB2, MySQL. Okay, this is something now. And we go with the near real-time data as the photos, web, audio, and all. And the real-time, actual real-time data is the social network data and video, the unstructured mobile information. Okay, mobile data. Okay, the mobile generates data, generated data. So the petabytes of data. Now we are working on yottabytes. Now the model has changed. The model of generating, consuming data has changed. Okay, it's an old model. So few companies will generate the data and all other users will consume the data. Okay, so for example, newspapers. Okay, we'll be reading the newspapers. Okay, they are generating data, we'll be consuming the data by reading. Otherwise, through news channels, we'll be collecting the data. Okay, generated data we are consuming. Now actually what the new model, all of us generating data. Okay, so all of us are consuming data. Okay, we are generating data and we are consuming data. So automatically the voluminous data is increased. So what's driving big data? Okay, so here it is, the complexity is increased, the business value also increased with big data. Okay, here we can apply the business intelligence. Okay, so when so for example, getting with respect to the customer feedbacks, we can change the products, otherwise you can improve the products. Then how can you give better way to satisfy the customers. Okay, these are business intelligence we can make it. So they're using ad hoc coding and reporting, can use the data mining techniques. Okay, here it is structured data is used, typical sources are available. Okay, using the typical source only we are using. So for example, we can take the Facebook informations are with the WhatsApp. Okay, this is we are creating the group. Okay, like that. So structured data we can make it. Small to mid-size data sets are used in business intelligence. Okay. The next is the predictive analytics and data mining. Here we have to optimize the data, and we have to using the optimization techniques, and we have to do the predictive analysis. We have to predict, okay, what's the future. What not from the past data. We have to use the present data, and we have to predict the future. Okay, then complex statistical analysis here it is used. Here we can support all types of data and many sources. It supports a very large data sets. Most of the time it's a real-time data. So Gardner specified the 3 V's. That's volume, velocity, and variety. Some people make the 5 V's, volume, velocity, variety. Then we added the 2 V's, veracity and value. Okay, so volume we know that's voluminous of data. So terabytes to exabyte to zettabyte. To now we are making the crossing of data as what in terms of yottabytes. Okay, so data in motion. That's what the streaming of data. Because of streaming data, that's what the data generated speed. Okay, at speed at which data is generated. Okay, so that's very important. Then data in many forms. So the variety is what data in many forms: structured, unstructured, text, multimedia data. That's what the video, audio. So that's what semi-structured data. So all these things are supported. And veracity. Okay, some things will be a vagueness. Okay, that's what data in doubt. Okay, uncertainty in the data will be there. Okay, so inconsistency, incompleteness of data will be there. Okay, so in that cases we cannot believe the data. Some we have to apply the that's what we have to apply some techniques to avoid the uncertainty. So we have to do with the model approximations. We have to do it to avoid the uncertainty involving data. And value. Okay, that's what the actual value with the data. Okay, certainty of the data, certainty of the value. Okay, data into now is money. Okay, if you are making the business models means motivation is what we have to. So profit is much important. Okay, the profit in terms of money. So here the volume. So the volume specifies the scalability. How much data is really relevant to the problem solution? Okay, there's a cost of. So what you can do, you can really afford to store across all the data. So now we are in 2020. We are asking actually now it is yottabytes. Okay, not only Z. Now we move to yottabytes. Okay, this is what data volume has increased. Okay, from 2009 to 20. Okay, so now it has increased into yottabytes. Okay, so 0.8 zettabytes to 35 zettabytes. So data volume is increasing exponentially every day and every month and every year. Okay, fine. Exponential increase in collected and generated data. So you can see the Twitter. Okay, so there also what the number of tweets generated every day is increased. So you can see here the Twitter, okay, 12 TBs of tweet data every day generated. Facebook generating 25 plus TBs of log data every day. And Google, okay, there's question mark. Okay, we don't know how much TBs of data is every day they generated through Google. Okay, and 30 million RFID tags are used. Okay, this was since 2005. Okay, 76 million smart meters are available, and phones. Okay, that's what the 4.6 billion camera Android, and hundreds millions of GPS enabled devices are available, and 2 million people are using. Okay, more than 2 million people are using web. So web also generated data. Okay, the variety. So next is the variety. So automatically all these sources are generating huge volume of data. So from the huge volume of data, we have to do processing, how to do analytics. So the variety, the relational data, it's also supposed to in terms of tables, transaction, legacy data, text data, that's mean the web, and semi-structured data is with the XML. Multimedia data is what with respect to audio and video. Graph data, which is using social network, and semantic work, this is the RDF, resource description framework. Okay, it's used. And streaming data. Okay, so streaming data is also with respect to processing. Okay, we are using Spark or not. With respect to that, streaming data supports. A single application can be generating, collecting many types of data. Some scenarios, single application generate collecting many types of data. For example, you can take the WhatsApp. Okay, the WhatsApp, the social network. So it generates what? The text, video, audio, image. Okay, all different types of data generated through one social media network. Okay, so big public data, this is what the online, weather, finance, and so there is a need of single data model to handle the diversity, because we are big data is what suppose different data formats. So the extraction of the knowledge. Okay, so all these types data needs to be developed. Okay, so a single view to the customer. So you can see here customer, a single customer, they may use the social media, Facebook or the Twitter, and finance. Okay, he'll generate the data through accessing the bank. Okay, banking or finance, and he'll be using gaming and our own history. Okay, so he may be a history. That's what the company. Okay, so that then entertain. Okay, he may be using Netflix. Okay, for entertainment and purchase. Okay, he'll be purchasing through Amazon. Okay, so automatically single user generating large volume of data and different formats of data. Velocity. So the speed, velocity represents speed at which data is generated. Okay, the speed at which generated, the same the data to be processed. Okay, the same speed data to be processed. That's why the data is being generated fast and need to be processed fast. That's very important in online data analytics. Okay, if you take late decision, definitely be missing the opportunities. So for example, the e-promotions. Okay, based on your current location, your purchase history. Okay, what you like, send promotions right now for store next to you. Okay, for example, suppose you are using Google Map. Okay, so while you are driving, so you are asking for the nearest location. Okay, so for example, even if it suggests, okay, for example, you feel sleepy. Okay, what you can do, that's what you can have your RF, that's sensors. Okay, sensors will detect. Okay, this will how if you feel sleepy. Using that, the sensor will detect. Otherwise, you can capture the image of the person. His eyes are blinking. Then what he may feel sleepy like that. Can give information, and you can suggest the user that the traveler you can take rest. Okay, so nearby hotels are available. So like that, recommendations. Fine. The next is healthcare monitoring. So sensors monitoring your activities and body and any abnormal measurements require immediate reaction. Any abnormal measurements definitely requires the medications. Okay, this is the healthcare monitoring. It's very important. So it's a need for streaming versus block approach to data analysis. So it's what streaming data should support and block of data is going to be used, because a large volume of data is generated, so you have to store in terms of blocks. Okay, that should be used for data analysis. So how to analyze the data is very important in flight and combined with data at rest. So that is very much important. So the one story I heard actually, that's what in WhatsApp. Okay, so a person is ordered pizza. Okay, through net. Fine. So maybe Domino or whatever it may be. That's what he came and delivered the pizza, and he's telling that. Okay, so he ordered the cheese. Okay, cheese pizza. So he's coming and telling that, no sir, you ordered the pizza, but we cannot deliver the pizza to you. Okay. So why? So here that the user, that's a customer who ordered pizza, okay, he was wearing a wearable device. Okay. So wearable device to calculate the what is healthcare informations. Okay. That's what the heartbeat rate, fine, and how many calories he used. Okay, so he taken everything which is recorded. So what will happen? He is getting information, and also he is telling that no, okay, no, I have taking medicines and I am taking what, doing proper exercise every day. So, but the pizza person that's was brought the pizza, he's telling that no sir, you have taken not taken medicine because we have checked your online transactions. Online transactions telling that and healthcare monitoring device is telling that you have not done any exercise for the past 10 days. So you that's what this you suppose you eat pizza, so your life will be in risk. Okay, that's what here that insurance companies are now. Okay, it's very important way to provide the insurance. Okay, insurance money to the customer or not. Okay, so they're tracking the customers. Okay, whether the customer is properly taking that's what diets, properly maintain the diets, and he's doing properly exercise and taking medicines. Okay, if there is any health issues happen, okay, they can track and they can tell that we cannot provide the insurance money. Okay, because medicines, he has not considered, he has not done any exercise, he has not taken care of his health. Okay, so like that's making. Okay, and again what he's telling that, for example, he's telling that the person no, I didn't use online transaction, I use pay through cash, I got the medicines. Okay, so what will happen now, he's asking for income tax. Okay, they're asking that what is the source of money. Okay, how you pay that cash. Okay, so this what will happen now, the many applications are interconnected. Okay, big data and data stored on cloud. Okay, so all these things are involved. So now what is what most of the insurance companies are doing research in this domain. Okay, so whether they can provide the insurance money to the user or not. Okay, by tracking them. Fine. So the real-time and fast data. So social media networks, it generates large volume of data. So scientific instruments, already told that. So mobile devices are tracking all objects all the time. And sensor and technology, okay, sensor, IoT devices again generate all kinds of data. So what will happen now, it's there is no hindered, okay, so hindered by the ability to collect the data, but the ability to manage, analyze, and summarize, visualize, and discover the knowledge from the collected data in a timely manner, okay, and with scalable support. Okay, so big data challenges, already told that. So it supports what, all type of data formats, structured and unstructured. Okay, supports a velocity, variety, and voluminous data, different variety of data, and it supports what generated data is very speed, and it has to process the data at the same speed. Okay, so what is the on investment is not always immediately obvious. Okay, so result of analytics may be available only after years following the prescription. Capabilities. So for example, you take the health care, so moving from predictive to preventative health care. Okay, so now we are moving for predicting the disease. Okay, from that we are moving to preventing. Okay, so how can you, for example, predicting the COVID. Okay, so through quarantine and social distancing and frequently washing your hands. Okay, that's what the preventive health care. Okay, so health. Okay, the enabling personalized medicine for shortened time to value. Okay, personalized medicines are telemedicines are available, and online medications are available, and health. Okay, recognizing predicting the spread of infectious diseases. Okay, so the Ebola, COVID, flu. Okay, then crime, aggressively recognizing and combating syndicated multi-party fraud online. Okay, so online cyber crimes. Okay, so okay, we can identify through the big data. That's a big data analytics. So crime, that's what the predicting potential crime locals and time to preventatively deploy police. Okay, so the next environment can predict the weather, floods, earthquakes, disasters. Okay, can predict the disasters in terms of flood, earthquake, heavy rain. Okay, and volcanic eruptions. Okay, earlier. So the computer security. Okay, so it's to predict the potential attacks. Okay, so for example, in Gmail we are getting mails. Okay, the spam mail or ham mail. You have to identify. There again, you have to collect the emails and you have to train the system to identify. Okay, whenever the incoming mails comes, okay, it's a spam or ham. Okay, so the already told the big data sources. So the different data sources are generating big data. So cloud, media, legacy documents. That's what we are giving online. We are submitting online transactions. Okay, cloud, web, IoT. Okay, sensors emits large volume of data. Sensors. Okay, the next social influencers. Okay, that's what the using Twitter and WhatsApp and Facebook. Okay, how they are generating data. Okay, different types, different variety of data. Okay, and voluminous data is generated. Activity generated data. Okay, so with respect to activity, okay, we are purchasing. Okay, through Amazon. Okay, so what will happen will be keep on viewing data, and sometimes you will be giving some inputs to the this with respect to this dimension you want to purchase some item. Okay, like this activity generated data and data warehouse and appliances, network in-stream monitoring technologies. Okay, the packet transferred. Okay, then what is a bandwidth usage? These informations are with the network in-stream monitoring technologies. Okay, then social network profiles. Okay, Facebook profiles, using the Facebook profiles, then databases. So what can we do with these data? Okay. Data aggregation is very important, and statistics. For data aggregation statistics, we can go with the data warehousing and online analytical processing. It's a traditional method. Okay, and we want to index and search and coding. We have to go with the keyword-based search. Otherwise, with the pattern matching. When you go the pattern matching, you have to go the XML and RDF. That is the resource description framework. So knowledge discovery that supports with the data mining and statistical modeling. Okay, data mining, we are going to extract the useful patterns from raw data. Okay, and data driven, the predictive analytics. Okay, so you are going to analyze the past and present data, and we are going to predict the future. Okay, the next is the deep learning. Okay, the deep learning is an AI function which mimics the working of the human brain. Okay, while processing the data, which is mainly used to deduct the objects, recognizing the speech. Okay, speech recognition and translating languages. Okay, and making decisions. So, for example, the traffic prediction earthquake warning. So it's Alex Bryan. He has done the study. That's for the traffic prediction and earthquake warning using crowdsourcing. Okay, crowdsourcing is what? Analyzing data from social networks. Analyzing data from social networks, our customer feedback, are the comments. Okay, with respect to the crowdsourced. Okay, which produces insightful, definitely produces accurate results because we are getting data from real people, not from the machines. Okay, So using the crowdsourcing and physical modeling can sense the data. Okay, so what data assimilation is applied? The traffic predictions are very easy to model. Okay, traffic prediction models developed, and earthquakes. Okay, earthquake warning alert messages whenever the disasters occurs. Okay, so here the geopast data is also used. Geopast means location. Okay, the location of the user is tracked using the geopast data. You can give alert message to the users. So the data science is multidisciplinary. Okay, so here it is a combination of machine learning, statistics, pattern recognition, neural networks, neural computing, and artificial intelligence, knowledge data discovery, databases, data processing, visualization. Okay, so mainly the user needs to have a domain knowledge and how to communicate, how to present, okay, and inquisitiveness, okay, then problem solving and business analysis, analyze, okay, and business strategy. Okay, so the next is how data science differ from database. In database, values are precious. Data science was cheap because we are getting large volume data from different firms, different users. Data volume is what so modest in databases, but massive in data science. So with respect to database, bank records, personal records, medical records. In data science, online clips, GPS logs, okay, global positioning system, okay, that generates data, tweets, and building sensor readings, okay, sensors again generate data, emits large volume of data. Priorities here, the consistency is supported with the database, error recovery is possible, and you can audit the database, okay, and so you easily recover the data, even data fails, okay, failure occurs. In data science, data's generated speed, available data is more, and query richness is supported. Okay, database support with the strongly structured because we are following the schema. Okay, so the relational database means relational schema. Object-oriented database means object-oriented schema. Okay, ODL, object-oriented, object definition language, ODL schema. Okay, data science means there is no schema because it supports large volume, different variety of data, okay, different forms of data. Database supports consistency, okay, consistency is ensured in database because it supports ACID property. ACID is what? Atomicity, consistency, isolation, durability. Okay, but in data science supports what? The CAP theorem. Okay, so consistency, availability. Okay, so here it's used. The next is the eventual consistencies they supported. Okay. Then next is the realizations. Okay, SQL. SQL is the database. Data science we go with the different forms of data are supporting. So NoSQL, MongoDB, Couch database, Hive, HBase, Cassandra. Okay, Flume. Okay, so different databases are available. The next is big data. When you have to compare with the big data. So with respect to the CAP theorem, is main with the consistency and reliability. Okay, consistency and reliability. So when you consistency and reliability, when you support the distributed database, you have to support the partition tolerance. Okay, data is partitioned. In distributed database, data is partitioned in terms of two terms. Okay, it's what replication fragmentation. Okay, you can replicate the data, and after fragmentation, you can replicate the data. Okay, so partition tolerance. Okay, that's also much more important. Okay, this is the with respect to the CAP theorem, which is support the data science as well as with the big data. Okay, big data also supports with the CAP theorem, but database supports the ACID property. Okay, but big data also supports with the CAP theorem. Okay, so big data is used by organizations to improve the efficiency, to understand the untapped market. Okay, enhance the competitiveness. For data science here, we are going to model the techniques and methods to evaluate potential of big data in a precise way. The 3 V's of big data are right, data set, and it is characterized by velocity, variety, and volume. But data science provides techniques to analyze the data. Okay? So, a large volume of data is going to analyze it using big data. So, most of the times we'll be using machine learning and data mining techniques. For data science, make use of machine learning algorithms and also using the statistical models to generate the predictions. Okay, and big data relates to more with the computer tools and software. Okay, so many big data ecosystem tools are available. Okay, and data science focuses on fully based on the business intelligence, also support with the data science. Then we go the business intelligence and data science. Business intelligence is about dashboards and supports the data management and arrange the data and produce the information from data. For data science, what it uses statistical modeling and it forecasts as well as it's a predict. Okay, by analyzing. Okay, what will happen? What could happen? Querying the past is the business intelligence. Querying the past, present, and future is the data science. Okay, business intelligence also handle the static and high structured data. Okay, it's only structured data, but data science handle complex multi-structured data. Okay, high speed, high volume, complex multi-structured data from variety of data sources. So when you compare the machine learning with the data science, machine learning, we can develop new models and we can have the mathematical proof for the models. We can improve the model, okay, by data cleans, relatively clean and small data sets. Using, by getting more knowledge on machine learning, you can publish paper very easily, but can explore many models and understand the properties of the models and develop the tools which can handle the massive data set, and using the artificial intelligence technology, we can take actions. So data science life cycle. So 5 stages of life cycle in data science. First, capture, maintain, process, communicate, analyze. Okay, capture, data capturing, that is data acquisition, data entry. Okay, how we are processing and extraction. Maintain, how we are going to maintain the data. Okay, using data warehousing. Okay, if you are using data warehousing, how to go the data cleansing part. Okay, and data staging. Okay, and data processing, data architecture. Okay, process, so data mining, clustering, classification, data modeling, and data summarization. Okay, so using data mining, you can extract useful information. Clustering, you can group the data. Similar information you can cluster together. In classification, you can classify the data. Okay, fine. In classification problem, you can ask the algorithm to predict a district value. Okay? Identify the input data as the okay, it's a particular class or the group. Okay, identify the input data is under which class. That's what we can do with the classification. Okay. You can do with the, that's what classification comes under supervised learning. Supervised learning. Okay. In supervised learning, we'll be having input data and we'll be having the output data also. Okay. So in supervised learning, we'll be having input as well as output data. Okay. So in unsupervised learning, we won't have the proper output. So there we can apply the deep learning models to extract, okay, to model the data, okay, this are to extract the information or to analyze the data, okay. So the clustering actually looks for training data that are similar to each other, okay, the groups, similar items are grouped, okay, that's what similar data sets, similar data are grouped together, okay. In association, okay, this one association can predict the attributes which they are commonly associated. Okay, when you go with the, for example, you're purchasing what? Keyboard, okay, otherwise you are purchasing your monitor, okay, through Amazon, okay. So what will happen? You'll be giving suggestions to purchase the keyboard, okay. While purchasing the keyboard, also, one second. Purchase the data. So while you are purchasing the keyboards, it will give the suggestions to purchase mouse, okay, as well as other accessories, okay, which is related to the computer, okay. The next is the data summarization. Okay, in some applications we have to summarize the data. Okay, how to summarize the data. So here the communicate. So data reporting, data visualization, how we are going to visualize the data. Okay, so how the user will understand. Okay, so then business intelligence, decision making. Okay, so in business intelligence again, you can also take the decisions. Okay, so the customers are satisfied with respect to the improve. Okay, or otherwise the particular data, particular product can be removed from the list itself. Okay, like that decision making can do it. And analyze. Okay, it's a predictive analysis and regression, text mining. Okay, you can use a qualitative analysis. You can do 5 stages of life cycle. You have to capture the data, you have to maintain the data, and you have to process the data and communicate and analyze. Okay. The next, data science applications. The data science applications comes under business, healthcare, urban living. Okay. So for example, the business point of view, a simple example I'm giving here is from car design to insurance, okay, to insurance visa delivery. Business are using data science to optimize their operations to meet the customers' expectations. So what's happening here? You can see the two-way street, okay, for the Ford Focus car electric car, okay, so how they're designed, okay, then they can fraud deductions, okay, will satisfy the customer, okay, they'll be happy to use the applications, okay, then e-commerce insights, okay, Domino's secret sauce, okay, that's what. Then next is what's possible using social data to select successful retail locations, okay. Social data, you can select the successful retail locations, okay, in which location, okay, the pizza is more, the customers are purchasing, more number of customers are purchasing pizza, okay. There you can open what? Few more pizza store, okay, pizza shop, like that. So next, healthcare. So when it comes to the healthcare, Here it is reduce the readmissions. We can give better care. So elderly people are widely using medications. Okay. So earlier reduction is very important. It's a preventive. Okay. It's very important, and it reduces the hospital readmissions. So better point of care decisions are supported. So the healthcare predictive analysis applications are widely used. And for example, medical exams at bathroom mirrors. Okay, so you can see here the one company is careos.com. They are providing smart health and beauty platform, okay, through bathroom mirrors. Okay, so here that by touching the mirror, okay, so it provides information, okay, about your health and beyond any beauty, okay, are needed, okay, that you can access to that. So what smart health beauty platform supported by the CAROS, okay, that's what the medical examinations you can done by bathroom mirrors, okay, urban living, okay, the urban informatics, which combines data science with unique challenges facing world-growing cities, okay, the smart cities. How we are going to avoid the traffic, okay, fighting crime with data predictive policing, okay. So if the people are more, okay, automatically what happened, the crime also will be there. So how it's going to predict it, okay. Then instrumenting the cities, that's why the smart cities are possible through data science. Then what can data science be used for? So used for anomaly detection, so fraud, disease, crime, to identify the fraud, to disease outbreaks we can identify, and crime, and automation decision making, background checks you can do it with the customers, and credit worthiness, okay, you can do with the banking transactions, and classifications, okay, you can classify the mails, okay, the important mail, junk mail, okay, spam, okay, like that you can do the classification to the mail server, and forecasting, okay, so sales forecasting, revenue, how can you generate the revenue, okay, and customer retention, and pattern detection. Here it is a weather patterns, financial market patterns, or can be identified through the data science application, okay, and recognition, okay, face recognition, voice recognition, text recognition are widely used. Recommendations. When you go with the recommendations, it's based on learned preferences. So many recommendation engines are available. Okay, that's supports. It's what recommends the your interested movies and very good hotels, restaurants, books that you may like. Okay, if you're watching one movie, okay, if you go to the Netflix or the YouTube, you are watching one movie, okay. So the right side is giving what? Lot of videos are coming, okay. So you are not asking all these videos, that is recommended by YouTube. Okay, if you're watching Netflix with the drama, okay, so with respect to the movie type is drama, it will be giving what? Other drama movies, okay, you may like to watch. So in restaurants, okay, in tourist recommendations, you can go with the restaurants, okay. This is what the user will give comments, okay. The user views can be used, okay. So user comments and review comments, based on the review comments, restaurants can be recommended to the users, okay. So widely used in tourist recommendation system. Other data science applications, transaction databases that already told that, recommender systems, Netflix, and fraud detection for providing security and privacy, wireless sensor data, smart home, okay, and real-time monitoring using IoT, okay. You can control your devices in your home, okay, from your office, okay, it's with the smartphone, and text data, social media data, okay. This is a product review, customer satisfaction. With respect to customer satisfaction, that's for the Facebook, Twitter, LinkedIn, and Amazon, okay, they are doing, okay, improving their revenue needs. Okay, so the software log data. Okay, this automatic troubleshooting. Automatic troubleshooting. Okay, Splunk. Okay, this is actually data to everything platform built for the cloud. Okay, it's a company is analyzing the machine generated big data via web. Okay, it's a company is analyzing machine generated data. Okay, big data via web. Fine. So next, genotype and phenotype data. Okay, genotype is heredity. Okay, that's what the disease. Okay, it's from the disease can be spreaded. Okay, otherwise can come through heredity. Okay, how can you predict? And phenotype data. Okay, so without heredity, by your eating habits, you may get some disease. Okay, you may get some disease. Okay, that can be identified. Okay, that's what patient-centered care. They are using genotype as well as phenotype data. Okay, and through that they're able to provide personalized medicine to the customers. Any doubts? Question session. Thank you for your patience by listening the session. Any questions?
Hello, Professor. Can you listen me? Am I audible?
Yes.
Can you please come again on genotype and phenotype data?
Yeah. Genotype data is what the disease you are getting from heredity. Okay. From forefathers. Okay. So, for example, cancer. Fine. Phenotype of data actually is what will happen if you are eating junk foods. Okay. With respect to your eating habit, we will be getting that's what will be affected by new diseases. Okay, that's with the phenotype data. It is not heredity basis. Okay.
Okay. Right, ma'am. Thank you.
Yeah.
Thank you.
For example, you are taking, you are eating more junk foods. Okay, so automatically cholesterol will be raised. Okay, so heavy. That's what more cholesterol leads to heart attack. And there will be block in brain. Okay, how the same way the block in brain also happens because of junk foods. And fast foods. Any more doubts?
Participants, you are requested to unmute yourself and you can ask your questions. Or you can type in chat box also.
Any doubts from the audience? Any more slide you want to clarify?
Professor, sometimes we get confused with data mining and data science because now again data mining is also being used very widely.
Yes.
With larger data sets, with variety of data sets, with velocity of data sets. So sometimes it's very difficult to tell the difference between these two terms.
No, actually data mining.
Like you have differentiated business intelligence and data science. Where, we got it, ma'am.
Yeah.
So similarly, can you differentiate between these two terms, please?
Yeah, data mining, you are going to extract the useful patterns from raw data. Okay, but there you are going to use, then you are not going to use any artificial intelligence. Okay, fine. Algorithms you are going to use in data.
Professor, nowadays machine learning, artificial intelligence, genetic algorithm, all these kind of things are being used in data mining research papers also, in research also.
Data mining is a subset of data science.
Okay, right, ma'am.
Participants, any more doubts or questions?
Vali ma'am, Professor Vikas Dubey has asked a question in the chat. Okay, he has asked about what is elasticity in big data.
Yeah, elasticity is not supported with the big data, it's in cloud. Actually, cloud supports the flexibility and scalability. Okay, elasticity is supported with the cloud. When you store the big data on cloud, okay, we cannot store the big data on our hard disk, okay, or the server because a large volume of data. So we are in need of cloud storage. Okay, they definitely support the cloud provider supports the elasticity.
Professor,
When the data size is increased, you can increase the instances, okay, the blocks. When the data, that's what the data size, that's what, for example, incoming data is less, then you can shrink the block. That's what
Professor,
Amazon, for example, Amazon S3 supports simple storage service. Okay, it supports, you can upgrade as well as downgrade.
Professor, in one of your slide, you showed a 5G of the business. Can you go back to the slide and explain us?
5G.
Yeah, 5G.
5G I make it. 5G is not.
Some business benefit in one of the slide actually. So 5G. Yeah, before this, some tabular column was there, green color. Yeah, sorry, here only. Okay.
It's not 5V only.
5V, sorry. Okay.
So actually, Gardner he coined the term big data first. Okay, so he coined only the 3Vs. Okay, volume, velocity, variety. Volume says 5V, scalability, voluminess of data. Velocity, the speed at which data is generated. Variety specifies that what are the different data formats supported. Okay, different data, structured, unstructured, semi-structured, multimedia, text. Okay, this is the variety. Veracity is what? Uncertainty. Okay, so that's what the vagueness in the data. Okay, you're not clear with the data. Okay, the vagueness. Okay, what you can do is researchers they are using upset theory to avoid the uncertainty due to that's why inconsistency. Okay, to avoid the uncertainty, you can use upset theory. Okay, missing values. Okay, the data in doubt. Okay, this was the veracity. The values were actual certainty of data. Okay, uncertainty is what veracity. The certainty of data is the value. Actual value. For example, you are making the business model means actual value is what? The profit. Profit in terms of money. That's the data into money.
Thank you, Professor.
Yes. Any more doubts?
Participants, if you have any doubts, you can please unmute yourself and I can ask your doubts. Excuse me, ma'am, I think no more doubts.
Okay. Dhanlakshmi ma'am. Yeah, thank you participants. Thank you Dhanlakshmi ma'am for providing great opportunity to deliver the lecture in ATAL FDP on data science. Thank you ma'am.
Thank you, Ali ma'am. First, actually, we should say thanks to you. You have given a wonderful session and you have explained all the basic concepts in a very clear manner. Okay, thanks a lot for joining here. Okay, we'll meet in the third session again.
Yes ma'am. Thank you so much ma'am. Thank you ma'am.
Valuable session, ma'am. I think most participants have got many things from you. Thank you, ma'am.
Yes. Thank you all. Can I leave Dhanlakshmi ma'am?
Yes, ma'am. Yeah, you can leave now.
Dear participants, please fill the attendance form. Next session begins by 11:45 a.m. Next session begins by 11:45. Please fill session 1 attendance form posted in chat box.